Okay, hello everyone. Thank you for coming. So I'm JF. I work at Woven by Toyota, and thanks everyone for coming to our third meetup related to C++ and technology here. For those of you for who it's the first time, welcome. For the returning ones, thank you for helping us create a community here within Tokyo around technology. So today we'll do a slightly different event from what we've done before. We'll have first a presentation and then a panel, and then we'll welcome questions from the audience. So think through questions and please line up at the microphones when you have questions towards the end. We'll call out when to line up. English or Japanese is fine for the questions. So we have three people here today. We have Brent at the very end, who is visiting us from GitHub. So thank you, Brent. He's going to give us a presentation. Then we have Juan here, who works at Woven by Toyota in security. And we also have Kjeld here, who works in security at Woven by Toyota. So that'll be our panelists today. So we'll start with Brent's presentation, and afterwards we'll do the panel. Thank you, everyone.
Thank you. My name is Brent. Let me get this. So I'm a field security specialist at GitHub. I've been at GitHub for about a year now. I've been in Japan for 23 years. Been involved in application development, application security for the entire time. So I've really kind of seen the whole industry around application security grow. I started off as a developer, moved into application security, and then before I joined GitHub, I was a CISO at a number of companies in Japan. So I've kind of seen it from several different angles. Today I'll be talking about integrating security into your build pipeline. So before getting into some of the details, I just want to talk about application security, like the evolution of application security over the last 20 years that I've been involved. And I break it up into different sort of maturity levels. So when I talk about application security 1.0, looking at organizations that go from really no application security to first implementing it. And usually this is some sort of security testing at the end of a development lifecycle. So this will be a pen test, in Japanese, usually called an application health check. But usually it's at the end of the life cycle. Security team organizes some sort of pen test, kicks the report back over to development, who then has to fix all of the issues within a very short period of time. It's better than nothing, but it's not sustainable at all, and it's usually organizations want to get past this fairly quickly into a more shift-left approach. So instead of doing things at the end of the life cycle, doing things more towards the development phase of an application life cycle. And each phase of the application life cycle, you can introduce different types of vulnerabilities, different types of security issues. And the farther left, the closer you get to where they're actually introduced, identifying them and fixing them, the cheaper it is, the better it is overall. And this shift left sort of mindset is what we refer to as application security 1.5. It's not really a full step evolution. And this usually manifests itself in adding security testing tools in various phases of the application development lifecycle. And the problem with this is that the security tools usually are designed for security teams. I think of them more as auditing tools. They're really tuned to detect issues or detect anything that smells like it could be a security issue and rely on humans to look through the issues and actually pick out the ones that actually are problems. And when you implement these at several phases, it does improve security, it does address issues earlier, but it doesn't do anything for developers and helping them fix issues any easier. They still have to go through and make sense of the output from these tools. They usually have to have a very short period of time that they have to fix them, and there's not really a lot of information on how to fix them. And then application security 2.0, that's what this is about, which is implementing security into the build cycle itself. So this is what would be, I guess, the full shift left achievement, where you have all of the tools, developer-focused tools, preferably built into the developer's workflow, built into the developer's tool set, hopefully. And we see a picture here on the left, and this is a GitHub pull request, and it has a security issue that displays right within that pull request workflow. And really, that's what we're talking about: adding all of the security checks within that pull request workflow. Now, Security 3.0, which I don't have any sort of slide for, this is really focused around prevention. Now, this is kind of a future state, and this is really talking about, at least at GitHub, when we talk about the AI-assisted security, so things like Copilot for security, Copilot for CodeQL, things like that. That would be what we'd call application security 3.0. But ultimately, it's very simple. Adding security into the build pipeline. It's actually, this is just a typical GitHub flow. We have the main branch of the application at the top, that purple line, and when a developer needs to do some work, they'll create a new branch, commit changes, submit a pull request, and then it gets reviewed, whatever the pull request process is, and then it will get updated and merged into the main branch. And I spend a lot of time at GitHub talking to security teams at various, I guess, levels of maturity, and really understanding this, this integrated security analysis, and that you can build, you can build an environment where you have all of the tools that you need within the developer's workflow. But there's sort of a, it's not just simply a matter of taking tools and putting them into that, the CI/CD pipeline. You have to make sure that you've tuned the tools so that they're really focused on developers being able to fix the issues, but not slowing developers down with false positives and having to deal with a bunch of non-issues. So some of the different things that I've listed: software composition analysis, secret scanning, static analysis, fuzz testing, coding standards. It's not an exhaustive list, but these are common things that most organizations that I work with will implement. The first one, software composition analysis. This is looking at dependencies in the application. So all the different components that your application depends on, really mostly looking at external dependencies, so open source or third-party components. And this is a particularly difficult area for C++. A lot of the other languages we deal with, it's quite a straightforward thing. There are very standard ways of defining dependencies within an application. And so this is a problem that we're working with, and how do we consistently be able to identify what's dependencies are contained within C++ projects. We do have actions that we're working on, custom workflows that will monitor the build process and identify the dependencies as they're added. But this is definitely something that should be added to this build workflow, just to make sure that developers aren't introducing new known vulnerabilities into the application. The next is secret scanning, and this is a very hard thing to see, but these two graphs are really just mapping out the attack vectors, common attack vectors for recent breaches. This is a study by IBM, and the horizontal axis is looking at frequency of these issues, and the vertical axis is looking at cost. What's the damage for these breaches? And the cause of the breaches varies from phishing to malicious insider. But way on the right on both charts that the furthest right purple dot and the most frequently, I guess, attack vector that's used by current breaches is compromised credentials. So this is a problem that we see that is growing, and actually most of the attacks come from, very simply, people are hard coding stuff into their applications or posting API tokens on public repositories. So having a secret scanning solution in place is very important to protecting and making sure that it doesn't get past your pull request. And this is also a good example of where you have tools that sort of need to balance you need to tune the tools to make sure that you're not slowing developers down, but you're catching what you need to catch. A lot of the secret scanning solutions are really designed for auditing purposes. So you point it at a shared drive and you run it, and it will catch anything that looks like it might be a secret, or it could be PII data. And then you have a human that goes through and filters out all the false positives, which is great for auditing purposes, but is not really sustainable for a build process. You can't slow developers down with having to deal with all these types of false positives. So making sure you have that tuning, and that you have the development teams and engineering and security understanding what's an acceptable level. Static analysis, this is a very big area. Static analysis, I think, should be built into any build process. But starting just with the compiler. Compiler is a static analysis tool in itself. It does do type checking, for example. That's nothing that you need to deal with, but it's always doing the static analysis for you. And you can use the compiler to report on security issues. I'm not an expert in the various C++ compilers, but I often refer people to the Airbus Security Lab breakdown of the various C compilers and different flags that you can set to catch various types of security issues. And then static analysis tools, so static analysis security testing tools, SAST. There are many different tools on the market. There are many different open source options. They all generally work the same way. This kind of goes through the evolution. Static analysis tools back in the, I guess, probably 2000. It was mostly just grep, looking for known, character strings that could be vulnerable. The problem was just had a very high false positive rate. So if you had a word that looked suspicious in a comment, that would show up as an issue. Then it sort of borrowed techniques from compiler theory, so lexical pattern matching, taking those character strings and turning them into tokens, so you can filter out things like comments or you have something that's much easier to search, but still you had a lot of false positives. You can identify things like dangerous functions, a lot of those in C. Things that you should stay away from. These are the sinks, things that potentially could be a security issue, but still, you can only look for instances of those potentially dangerous functions that are called, and there's no real analysis for whether there's a security issue within that particular call. So then, kind of expanding more, adding things like abstract syntax tree or control flow graph to map out the application, into a tree structure and to map the different possible flows of the application. Helps you query the application in a much more efficient way and filter out a lot of the false positives that you'd normally get with just basic matching. And the ultimate goal is to get to full data flow analysis. So you have the sources here on the left. These are untrusted input. It could come from an external source. And then you have sinks, which are these dangerous functions, potentially dangerous functions. You want to map that data flow path to see if there's any untrusted input, any sources reach those dangerous functions or the sinks. And then taint tracking, which is being able to mark input when it comes into the application as tainted, and then follow it as it moves throughout the application, that data, and being able to take away that taint flag if it's been sanitized. So, if you fix it in one place, it doesn't flag issues in all the different places that potentially untrusted or that untrusted input could be used. So at GitHub we have CodeQL. This is our static analysis tool. Very good at the data flow analysis, taint tracking aspect, and has a query language that you can use to query the application with a high degree of flexibility. There are open source queries available for not just C and C++, but all the languages that it supports. But also it allows you to extend it. So for things like coding standards, in the automotive industry, this is quite common, MISRA and AUTOSAR. But if you have other industries that have their own coding standards, or your organization has its own internal coding standards, these can also be codified into CodeQL query packs and run against, integrated into your build process, so you can ensure that any new code that gets pushed into the repositories is compliant with these standards. Another common security control that we see added to the build process, particularly for C++ projects, is fuzzing. So this is testing the application with various types of input, mostly unexpected input. So you're trying to input data that the application wouldn't normally handle to see that to see how the application handles it, if it blows up, if it has any issues, and that could lead to security issues. So this is a very common one for highly critical environments. This is compiler sanitizers. This goes back to the compiler flags. So these are at runtime, added to runtime to look for certain types of memory security issues. But yeah, really, it's just another one of those flags that you can set. And then this is not necessarily in something that you set within the build process, but looking at mitigations from the desktop world, particularly for C++. For Microsoft Windows, for example, you have address-based layout randomization and data execution prevention, which helps to prevent attackers from being able to figure out where code is residing or data is residing within memory, and will prevent data from being executed. So this prevents a lot of different types of attacks. That is set on the desktop though. So. But it's just another thing to keep in mind. Control flow guard is something, again, with Microsoft operating systems that you can set within Microsoft, in the compiler, to make sure that's built in, and then also on the platform. And then there's ARM mitigations, cherry, memory tagging extension. So these are all things that you can consider, or you should consider. When developing C++ applications, consider the platform-specific mitigations. So kind of going back to the discussion around the application security 1.0, 2.0. So this is what application security looks like in the SDLC. So on the right side, we have the typical software development lifecycle, where we have code test, code review and commit, CI testing, CD, QA and integration testing. And with this sort of classical 1.0 um, uh, security, application security, you have that hard security gate right between integration testing and production, the ship. So this is a huge source of frustration, I think, for many teams when they have this kind of application security. And the goal is to go from this to 2.0, which is having application security through DevOps or DevSecOps. So you're implementing these these controls within the build flow and the CI/CD pipeline, at all the different phases. So during coding, during pull requests, CI testing, CD integration testing, and so on and so forth. Just one other note, and this isn't really about integrating into the build, but another thing is inner source. So inner source is what we refer to as taking open source kind of methodologies or concepts and applying them to an enterprise environment. So instead of having various development organizations within your company, having one organization where everybody's working from and can share code. And ultimately for security, the most secure code is code that's already been developed and tested and used in many different places. So this is all about reuse and making sure you don't have to build the same thing over and over again. So that's a very quick overview of building security into the build pipeline. I think we will move to the panel. Thank you.
As we'll set up the chairs and then get ready for questions. So if you have questions, please line up at the podium. We'll take questions in order. Japanese, English, totally fine. So please come up to the stands while we set up. All right, don't be shy. Please come up. I'll have to feed questions otherwise. So thank you, Brent, for the overview. And we'll move to the panel now. I guess I'll seed the panel with a discussion on fuzzing, maybe. So I know a lot of folks are interested in fuzzing these days. We're certainly very interested in it at Woven by Toyota. We found that fuzzing tends to find a variety of issues that developers just never think of. And I know that Juan in our team works on that quite a bit. And so I was wondering if you could tell us what you think the advances have been in fuzzing in the last few years. Like how much better has it gotten compared to just manual testing and fuzzing itself getting better over time?
Thank you for the question. Hi, everyone. Well, fuzzing has seen several breakthroughs in recent years. It starts from having more accessible ways to instrument the program, lots of tooling, also tutorials available. In general, the security community has been able to communicate what they're doing in a more straightforward way so that many developers can actually integrate that as part of their process. And also, there seems to be a very nice integration from academia as well, improving into some of the tooling in order to explore programs in a more reasonable way.
Yeah. And another interesting tool that you talked about was static analysis, Brent. And I know that's also a field that's changed quite a bit recently. And I think CodeQL does a lot of things that I find exciting. So I've mostly worked on compilers my whole life, using static analysis as well as creating some and deploying them at scale. And my impression using these tools is fairly often the attackers you're trying to defeat are using those tools as well. CodeQL in particular is very popular with attackers to find issues because it's so malleable and has such a wide view of your code base. And so I was wondering if any of you could offer us anecdotes of really finding deep bugs in different code bases based on static analysis.
Um, yes, this is a very interesting loop. Uh, Static analysis and dynamic analysis go hand by hand. You really want to know what are certain places where it is good to search for dangerous functions and like the sinks that we saw during the presentation, and being able to have this kind of tooling to analyze the program and see where the natural software development process can become more effective is definitely very, very useful. For example, Kel, like you have a lot of experience with the static analysis. How has your experience been with C++ so far?
Um, so for C++, I think CodeQL has been actually quite great here. I think because the language evolves quite a bit, it's difficult to fine-tune some of the rules for C++, and so dealing with false positives can be quite tricky. And then tracing down whether something is actually a false positive, going through code bases is very tricky. But one thing I'm actually interested in, if you're saying SAST and DAST go hand in hand, is when you find a problem in DAST, right, you do fuzzing, and then you may be able to generate some SAST rule based on your DAST finding. Have you done anything like that? Have you made any SAST rules or anything that you think could be a CodeQL rule based on a DAST finding?
Yes, that's something we've been working on. It's not always easy to create a rule that exactly matches, and depending on the context, it could be hard to represent. But in some situations, for example, if there is some kind of function in the standard library that behaves in a way that people do not expect, there are some things that you could definitely translate into CodeQL, such as the presence of this constructor could be troublesome, or the presence of these combinations of functions in a given file or in a given library can be something that would help to avoid some kind of pitfalls that the dynamic analysis can find. Something that may be a little bit difficult to represent, for example, is the contracts of the function. As CodeQL, well, we have the expert here, but it's his representation of the program, right? And that doesn't include the comments or the way to use it.
Right.
And yeah, I was actually wondering, how would you deal with comments in CodeQL, for example?
CodeQL doesn't deal with the comments. But to kind of go back to the point that you made around that sort of feedback between DAST and SAST, we have seen cases, and just recently, I know Mercari published an article what they're doing with CodeQL by taking sort of other security testing that they do on their applications, such as DAST. When they find issues that aren't caught, through SAST, they can codify those. They'll write CodeQL queries and then add that to their build pipeline, so that those are caught much earlier in the cycle the next time around. So
Yeah. So
there's
for
a lot of
Oh, sorry. So for example, they might do manual testing as well, and then
Yeah.
based on the manual testing, they find some kind of vulnerability, and then put that into a query, and then run it on further tests, or
Right.
try to catch this same problem earlier in the development lifecycle, that sort of thing.
And yes, exactly.
Yeah.
And you can also expand or narrow the scope of the queries. So by default, as I said, it's a developer-focused tool. The queries are really tuned to be, to have the low false positive rate, and really to identify the issues that we're very certain, high confidence that these are security issues. Obviously, you can adjust that, but with the security, issues, some organizations want to have a broader set of security. They do want a little bit of maybe manual checks to confirm, maybe medium confidence level as opposed to just high confidence level. to your point, in terms of compliance. So if you've got your own set of compliance-based queries that are in order to meet some sort of regulatory requirement, you can sort of start those wide and then adjust them and test them, and as you see those in the wild and see areas where you might have a high false positive rate, and you can limit or narrow the scope of the detection without impacting the compliance aspect.
Okay, so do you see many companies building their own security query packs, or would you say most of them rely on the existing ones, which you say are kind of tuned for low false positive rate?
So most use the existing. So there's three packs. You have the security pack, which is the high confidence, low false positive pack. You have an extended, which gives you less high confidence results, and you have quality. So these would be more code quality issues. But we do see a lot of organizations build their own.
Okay, and then if the philosophy is, again, for these security packs, low false positive rate, then what about the compliance packs like MISRA and AutoSAR packs? It seems there it's important that we catch everything. It's critical, actually, that for compliance everything is caught. So what's the philosophy there with those packs?
Well, I mean, these are, so the packs that we have for MISRA, these are open source. It's a community effort, and it's kind of a dance between compliance and security and engineering, because for compliance-based rules, the tendency is to do more of an audit-based approach, where you want to catch everything and you want to do a double check to make sure that things that are flagged as false positives really are false positives. So there's a lower threshold, I guess, for risk threshold in those. So I think a lot of that's driven by compliance departments or compliance teams, and is really based on, I think, a risk threshold for different organizations.
Okay.
Or system. If it's a critical system that's related to human life, you're going to have a much higher threshold.
Yeah, thank you. So we have a question on the microphone. Please go ahead, and please speak slowly for the interpreters.
Yeah, thank you. Thank you for the great talk. And I must say, as a non-security person, I am more interested in kind of the reverse of what you just talked about. So for me, it's more, I run static analysis, and I get a lot of errors, and I don't really understand them. And it tells me, oh, this variable could be null. And to my mind, it seems impossible. So how close do you think we are from a tool that could tell me this is the issue and show me an example of when it would be an issue and tell me how to fix it? Because that's ultimately, I think, what we really care about.
I would say personally, CodeQL does a good job of that, but I'm biased. It is, tools vary in what sort of information they provide. Most of them are based on a standard format, serif format, which has defined fields for things like description of the issues, how to fix it, sample code. But I don't know. What's your experience with other tools?
Well, there are limitations on what a static analysis tool can do. I mean, they don't run the program. They just assume that everything is reachable, and they can do some filtering. But to really determine at some point, that's where the dynamic analysis part comes in. One way could be, well, generate a program that crafts some inputs and that it can actually show that it's null. If you can eventually show that it's not null, then probably you need to go on the way, and you have one of the noisy cases that Keld was mentioning previously, in which case, well, there could be several ways of dealing with that depending on what kind of application you're trying to develop.
I guess what the question is also about is not so much how do we verify that there's a problem, but more like, okay, let's say we have verified it and the developer gets this output. How can we make it as nice as possible for them to know, okay, this is where the problem is, here's an example of the problem, and this is how you solve it. And I think um, it really depends a lot on where you have your code and what tools you're using. For example, CodeQL integrates pretty well with GitHub, of course, through GitHub Advanced Security. And then I think as a developer, you can have a pretty good idea of this is the problem, this is the exact place in the code where the problem exists. And depending on the quality of the query pack, some instructions on how to solve it or how to fix it. Um, so yeah, I think it really depends on the tools you're using.
And a lot of the direction that we're going with it at GitHub revolves around Copilot and AI-assisted tools. So you can there's some experimental tools that you can use with brushes for fixing security issues, but that's definitely the direction we're going in the future. I think we have another question.
Thank you. Please go ahead.
Yeah. Hello, thanks for the talk. So I'm in three teams. So about some new trends on static analysis. So I think one of the big issues that static analyzers are pretty good to analyze like flows related to standard libraries because these are known. But when you have something more custom, as you mentioned before, it might be a bit harder for the static analyzer to say, oh, this is an allocation or this is string format whatsoever. And recent trend that I see is like to add some attribute or some hints to a static analyzer. So one typical example is GCC start information 10 added the F analyzer. And this one goes in pair with a set of attributes. So for example, there is a format, the printf attribute to tell that, hey, this is a string format. Or for example, a tainted attribute added in GCC 13 to say, this source, this is an external source, so we have to sanitize this input. There is also, for example, the allocator deallocator attribute to say, this is a memory allocation deallocation to find some use after free. So right now, I think this is something very new, so I just wanted to know your opinion of like how much those kind of hint could help the static analyzer to be more efficient for some, how to say, more like outside of the libraries to be better to analyze like user code, custom function, things like that.
Thank you.
I think that it would be very interesting to have such information, for example, consumed by CodeQL, but I guess I worry if it's very compiler specific, would a tool like CodeQL consume such information, or would it not?
Yeah, I mean, that's one. I'm not too familiar with that area, but yeah, I think if it's too specific, yeah, I think it's something that you'd have to build, something very custom for that case, or if it's only specific to one organization, yeah, it'll be very hard, I think, for it to make that determination. And I think that's something that may be going in more the AI direction in the future, is trying to pick out these kind of more niche cases and kind of generalizing them. But
okay, and maybe until then, you can take CodeQL output or any, I guess, static analyzer output and sort of augment it with this additional information you get, these hints you get from the compiler, perhaps. Like, CodeQL has flagged a function, and from these hints, these typing hints, that it takes unsanitized string as input, and then maybe you can use that to make a judgment call, something like that.
Yeah, something I found promising is adding type constraints where C and C++ are very open on types, especially the C types like arrays. So there was a talk at the LVM developer meeting a few weeks ago where I think it's called the F bound safety, the compiler flag. And that allows you to annotate your code with bound safety instructions. For example, this pointer is never incremented or something like that, or things like that. And I think that refers a bit to what you're saying. In this case, there's some runtime attribute and some compile time attribute. But I think there's a lot of interesting things that if you could manually opt out of would be fairly powerful. Same thing with, say, contracts or something like this. If you could give a range to particular inputs or post conditions, you could prove within that range it's okay and things like that.
Maybe to bounce on the comment like, hey, this is not standards yet for now. Like the example I said for GC, that's for now GC specific. Maybe a question more to GF, like how much feasible you think it will be to have, for example, to the C++ spec, like, hey, the tainted attribute is a now valid C++ attribute. So I think like GCC has been a big driver to this kind of simulation, like something which is advertised by GCC, which is used a lot, eventually, which is a standard. So for many attributes, sometimes it's renamed because, like, for whatever reason, there's some clash. But initially, the attributes, even those which are standardized today, are, I think, often compiler initiatives, or at least it used to be. So I think how much realistic would it be to, in a future GCC, to have those printf attributes, string format attributes, malloc allocator, deallocator attributes, tainted attributes, so that every tool can know for sure, like, hey, now this is not GC fantasy, it's something we can rely on.
Yeah, I think for C++ it's doable, but I think for C it's tricky because C tries to be able to have multiple implementations that are fairly small, and so when they add attributes, they're more conservative about it. Whereas I think in C++, the tendency has been until recently to rely on tooling vendors to offer these things. And recently, there's a lot of interest in the community and in the C++ standards committee to improve security and safety. And so what you described is possible. If you want to help it happen, we should talk after.
Yeah, I think my question is how much it is feasible for C++ because I don't see it coming for C so far, as you said. And for C++, on the contrary, I think it is in the domain of feasible in the next couple of years.
Yeah. But the two languages do try to sync on certain things. And so when C++ adds a thing and has deployment experience, when it fits well, when it's designed to fit within C, the C committee then usually takes a pretty close look and more or less adopts it as is.
Well, the fact is that those which I mentioned, so it initiated a lot from the C, I think. So, for example, when you write project in C, because there's unsafe pattern, like allocation deallocation, you don't have a spike point, anything like that. So there is huge incentive in C to have those flags, those attributes. And so, for example, if you take the Linux kernel, for example, now spend more and more effort to decorate those things so that even if the C language is not aware of it, once it's decorated, now you know for sure the compiler, the static analyzer, can say, yeah, this, I don't know this K3, this K-alloc function, but now it is decorated, I know it's a malloc, I know it's a dealloc, and now you can analyze it as if it was a library, a glib, a CLib library, etc. So actually, this initiative comes from C, but I think there will be a huge benefit to standardize and like rely more on the C++. I didn't see it so much in C++ project, honestly, but this is successfully used, for example, in Linux kernel. So, and that's recent trend. I think that's a nice thing to do in the future.
Yep. All right. Next question, please. Please make sure to speak slowly for the interpreters. They were laughing earlier.
I will try to speak slowly, and I will have a question for Brandon, and thank you for this presentation. And I was curious about, is there any feature like implementations that's for the GitHub that's gonna be like correlating with the same invariant finding? For example, been raised by CodeQL result as a SAS finding, and then Fuzzerkin can catch the same finding as can. Is there any feature upcoming in CodeQL for issuing, and that we can have more confidence on having correlating with both scan approach.
So let me see if I understand. So you're running, I guess is the question, you're running two different tools, CodeQL and another tool, and
Yeah, like an example
if it
that
catches the same.
yeah, yeah. For example, in the fuzzing in the presentation, I think it was in Google Test.h. So that's the Google's fuzzing framework, and then like picturing is we are scanning a C++ project where the SAST, CodeQL, and fuzzing is found the exact same issue.
Yeah.
So how is there any feature is coming for the CodeQL that as a user that we can see that over the CodeQL, sorry, GitHub.
So you can see that it's already been caught somewhere else.
Yeah.
And
Yeah.
no, there's no feature at the moment, nor in the roadmap at the moment.
Okay, understood. Thank you.
It is definitely something that's requested quite a bit, and I think there's a whole kind of new category of tools for correlating different testing tools findings and making sure that any overlap is only reported once. But yeah, that's kind of an evolving area in general.
Great, thank you.
All right, thank you. Next question, please go ahead.
Can you hear me? Hello. So thanks for the presentation again. So you guys talked about fuzzing right now, right? So is the fuzzing testing, or is it like something similar to property-based testing that are you guys familiar with that? Maybe property-based testing?
Yeah.
Yeah. So how easy is it to convince the engineers in your team to write property-based tests compared to unit tests? Because in my team that has been some problems, because writing generators takes a lot of time, and they think coming up with custom unit test examples is much better than writing your own generators to generate the random examples. So how did you guys do it in your team?
Okay, that's an excellent question. Relates to the human factors of developing. How much effort do you want to invest? Property-based testing. So we have several layers of fuzzing. The ones that are at the unit test level. Yes, there's a lot of property-based testing there. If you can convince the team of the benefits, it can really help you maybe reduce the amount of unit tests that you have. That's something you can come up with when you're trying to sell the idea. If you see that definitely it's not feasible due to some deadline and stuff that goes outside probably the security interest of the project, something that you may try to do is to fuzz in a different. You can still try to fuzz existing applications, like complete builds of the product that you're trying to ship. Those may be less effective depending on the kind of fuzzing that you're making, but it can still help you find issues in what you're doing. But personally, I do believe that property-based testing is something that every team should be doing.
Okay. Yeah, and are you guys using? So I use the closures, Clojure, and they have the functional languages have a lot of property-based testing examples. So are you guys using that functional programming languages or any other library that for PPT?
In particular for C++, yeah, we do try to implement the invariants with the existing assertion libraries or something that is comfortable for the team to use. But trying to add a heavy framework on top of the existing ones may be overwhelming in some cases. So we've tried to stay as lean as possible. Because you also need to integrate the fuzzing in some sort of compilation process. And that's a lot of tooling for developers to absorb, usually.
Okay. So you guys are building your own tools for that?
There's some combination of open source tools that we use, and we try to simplify the process for the developers so that they don't need to worry how, for example, the test is going to be run. Mm-hmm. Just write this unit test and we will take care of running it, things like that.
Okay, I see. I think that answers my question. Thank you. Yeah.
All right, thank you. Next question, please go ahead.
My question actually kind of relates to the last one a little bit. I'm not terribly familiar with fuzzing, but I've played around with it in some of my own personal projects that already had a significant number of unit tests. And I found that when I kind of just integrated it at the unit test level, the testing cycle got a lot slower to actually go ahead and do all of those. And I was just wondering if you had any sort of advice as far as if there's a time when one might prioritize doing fuzzy testing or fuzzing in some areas over others, and if you had any other thoughts about kind of how to speed up that cycle even while doing fuzzing.
Excellent question.
Popular topic.
Well, let's say given that you have already an existing project, there are several ways of thinking about this. Some security researchers go more on the sides of try to fuzz what hasn't been tested already, hoping to expand what you have already with a smaller amount of effort, which is kind of like what property testing gets you, right? But if you already have existing ones, yes, the search for bad cases can get pretty slow. So maybe something that we do is usually at the different CI stages, we invest as much effort as we consider necessary. For example, during merging, we just want to test that the tests work and that they go through some basic coverage metrics. But maybe in a process that goes not blocking the CI, but more on trying to test the application continuously, we can be more thorough in what we're trying to find. But yeah, it ultimately depends on what kind of applications you have. Something that may be worth investing time is taking a look at dangerous functions, usually overflows and application and parts of the program that handle input and output, like memory allocation, are usually good points to start with.
Thank you very much. That's very helpful.
All right, thank you. Next question, please go ahead.
Thank you very much for the presentation. I used to work on C++ and also some of the DevOps. So one of the problems we used to have is when people we have a pipeline, we also have some SAS analyzer, maybe DAS as well. So when people create their own side project, and they finally decide, oh, I want to release this thing, they try to merge the main product line. And usually there's a lot of conflictions. I mean, not only the code conflictions, but also compilations. And it breaks everything. It breaks the SAS, breaks the build CI, breaks the SAS, breaks everything. So I only see nowadays the pipeline is getting more complicated. So do you have such kind of a problem? So for the CI, it looks more like a security product. How do you ensure the developer's user experience about it? Thanks.
Let's see if I can speak to that a bit. So I think there's a few different things you can do and that we try to do to make it easier for developers. One big thing is this whole idea of shifting left, and we can even take this as far as shifting it into the code editor that you're using. So for example, SCA checks or even SAS checks like CodeQL, you could run it locally on your own code, and then during development, every now and then it will run it. Things like secret scanning, you can do it through pre-commit hooks, linters also through pre-commit hooks. I think that's one way to try and catch things very quickly while you're developing a new section of the code, and to minimize the amount of effort you have to deal with when you try to merge something in. Maybe does GitHub offer any plugins perhaps for editors that people can use?
For security tools?
Yeah.
Yeah, GitHub has some plugins for editors like VS Code. There's a lot of open source plugins as well that can help display SAST findings within the IDE itself. And depending on what SAST tool you're using, that could be plugged into the IDE as well. But yeah, I mean, as you said, the CI pipeline gets very, very complicated, and yeah, we see that definitely continuing. I think there's something like 20,000 different actions on the GitHub marketplace. You know, people have thought to do all kinds of things. So, yeah.
All right, thank you. All right, so we're going to wrap it up. Thank you, everyone, for coming. I hope to see you again next time. We hold these events maybe every 3 to 4 months, announcing it on various social media channels. We're going to post the video on YouTube. We'll send a survey to attendees today, so if you have feedback, please write us back on feedback for this event, what you'd like to see next time, things like that. YouTube as well, you can leave comments. We do read the comments. And in particular, thank you for our panelists today. So we have Brent from GitHub, who presented earlier in the discussion. And we have Juan from our security team, as well as Kel from our security team. So thank you, everyone.
Thank you.